Okay, so we're just going to go through two, maybe three examples, and I'll have you grab some whiteboards, and I just want to practice the chain rule over and over and over again. Okay? Okay, be careful. What is our outermost function? Well, 2 is the constant that's multiplied. Okay, remember in that it's just going to go along for the ride. So let's ignore the 2. Okay, tangent is inside of the cubic function, right? So the first thing we have to do for our chain rule is the power rule. Okay, so we have 2 times our power rule. 3 tangent gets 1 less power. Okay, then what do we need to take the derivative of? What? Okay, so inside of our cubic function was tangent. So what's the derivative of tangent? So secant squared, where we keep the inside. And then we still have something inside of secant, and so we have to take that derivative.
I'm lost after x plus 2 squared. Why do you have all that extra? The secant squared out the way that.
Okay, so the first derivative we took was for the cubic function, but inside of the cubic function was tangent. So this was our power rule here. Well then, since inside of our power was tangent, we had to take the derivative of tangent, which is here. Okay, the derivative of tangent is secant squared, but we have to keep that angle the same as what we see up in the original. Okay, and then once we take that derivative, inside is this x plus 2 squared, so then we have to take that derivative. So it's like we applied the chain rule 3 times. Are you with me?
So I understand the secant squared, I just don't get what you have after that, the x plus 2 squared.
Okay,
Again.
so since inside secant squared is x plus 2 the quantity squared, we have to take that derivative. So I did the power rule here to take that derivative. So whatever inside our function, we also have to take that derivative after. So we started with the cubic function and took that derivative. Then we squeezed inside and we took the derivative of tangent. And then we had to go inside even more to take the derivative of what was inside.
I understand the derivative of what's inside, I just don't get why you have to rewrite after secant squared.
What do you mean he's bringing along the x plus 2 squared? Like that second.
Okay, so why, like both of these?
Yes.
Yeah, like I understand why it's after tangent squared, but I don't understand why it's after secant squared.
Because it has to stay the same. So whatever our angle is, right, because we're working with trig functions, whatever our angle is has to stay the same. Like it does not change. If that were 15x, I would have 15x in both of those. Like whatever the angle is for your trig function stays that angle when you're taking the derivatives. Okay? Like for example, if we had just the tangent of 15x, right? Then the derivative would be secant squared of 15x and then times your chain rule 15. Like you just have to keep that angle the same. If it was the secant of star, then our derivative would be secant star tangent. Star, that was a terrible thing. Okay? It just has to stay the same. Does that make sense? Okay. Let's dial it down a notch. What is being squared? 1 minus 2x. Okay, so the reason why I wanted to do this one is because of where the square is. So over here we have the cube on the tangent. Over here we have the square on the angle. Okay, so what is our outermost function in this case? Cosine. So that's what we have to take care of the derivative first. So the derivative of cosine would be negative sine, and we keep whatever is inside. Okay. Then we can take the derivative of what is inside. Inside we have kind of a power rule, chain rule situation, right? Where we have something raised to the second power, so we can do that power rule. But then we have something inside of that. So what's the derivative of that inside? Okay. So if we were to rewrite this to make it look pretty, we would actually end up with a positive 4 times 1 minus 2x. I'm not going to write to the first power. Times the sine of 1 minus 2x squared. I like to pull my polynomials out in front so it doesn't look like they are attached to the trig function. Yes. It would not be, because this is negative and this 2 is negative, so we can multiply them to make it positive. You are welcome. Okay, we'll do one more. That's 1 minus 1 over radical x, the quantity squared. Okay, outermost function. We have something squared. We need to take care of that first. So we're going to do the power rule. Now we got to take care of the inside. Okay? Now, I feel like we've been doing derivatives for a while now. We can maybe do some rewriting in our head, right? This is 1 minus x to what power? Negative 1/2. So when we take the derivative of 1 is 0. So we have negative x to the negative first that we have to worry about. Negative 1/2, excuse me. Negative x to the negative 1/2. So when we do the power rule, negative 1/2 x to the negative 3/2 would be that derivative of the inside. Right? Negative 1/2 x to the 3. Okay? So then if we were to make this look a little nicer, 2 times 1/2 is 1. So we have x to the negative 3/2 times 1 minus x over radical x. Okay, I'm not super concerned about you like multiplying that out and rewriting things. Okay, I just need the basics. Now, what day is that? Friday is our quiz. Okay, tomorrow is a pep rally schedule, so we do get a little bit of shortened time. You will get a review tomorrow, and I do want to spend a good chunk of time giving you some work time, okay? But I want to also catch a couple things now. So what I'd like you to do, I have marker boards, I have markers and erasers. I do not think that I have enough erasers for everybody, okay? I should have a lot, but I do not have a lot of markers. Where have all my markers gone? Okay, what I'll have you do is, okay, there's an odd number. How about, let's just see how many markers we have. Everybody grab a marker, 2 erasers per table, and everybody gets a marker board. We'll see how many markers there are.